Now, we're going to do our initial definition of the trigonometric functions. To start with, trigonometric functions will only be defined for an angle theta that sits inside a right triangle. This means, of course, since it sits inside a right triangle, the angle must be acute, less than 90 degrees. Now, it will be very convenient for us to have labels, okay? So I'm going to label the sides and the hypotenuse. Okay. Now, there are 6 trigonometric functions. Sine of theta is defined to be b over c, the side opposite divided by the hypotenuse. Cosine of theta is defined to be a over c, the side adjacent to the angle divided by the hypotenuse. Tangent of theta is defined to be b over a, the side opposite divided by the side adjacent. Cosecant of theta is defined to be c over b. Secant of theta is defined to be c over a. And cotangent of theta is defined to be a over b. Now, I don't expect you to learn these based on a's, b's, and c's. Okay? The easiest way to remember these is using the acronym SOHCAHTOA. So this is warning number 24, to not forget SOHCAHTOA. Okay? So, this acronym tells you how to compute sine, cosine, and tangent for any acute angle. It says that the sine is opposite over hypotenuse, that the cosine is adjacent over hypotenuse, and that the tangent is opposite over adjacent. Now, once you have those 3, you can get the remaining 3, because if you'll notice, cosecant is just the reciprocal of sine, secant is just the reciprocal of cosine, and cotangent is just the reciprocal of tangent. Okay. Now, another thing I want to point out before I do an example is to not forget the Pythagorean theorem. The Pythagorean theorem is one of the most useful tools in trigonometry. And if you remember, for a right triangle like this, the Pythagorean theorem says that a squared plus b squared equals c squared. This means if you know any 2 sides of the triangle, you can always find the third. So, we're going to do an example. Okay. Suppose that the adjacent side is 3 and the opposite side is 4. I would like all 6 trigonometric functions for that angle theta. Well, in order to do this, I'm going to need to find the third side first. Let's call it c for the moment. According to the Pythagorean theorem, 3 squared plus 4 squared must be this c squared. So 9 plus 16. This tells us that c squared is 25. Okay. We take a square root of both sides. We get c is plus or minus 5. Now, how do you choose between those values? Well, you do so by remembering that this is a triangle, and these are the actual lengths of its side, meaning I could get out some kind of measuring tape and measure it. And it is impossible to have a negative length. So in this case, our hypotenuse is just 5. So now, the sine of theta will be opposite over hypotenuse, 4/5, which means that the cosecant of theta is 5/4 because it's just the reciprocal. The cosine of theta is adjacent over hypotenuse, or 3/5, which means that the secant of theta is the reciprocal, 5/3. The tangent of theta is opposite over adjacent, or 4/3, which means that the cotangent of theta is its reciprocal, or 3/4. Okay, so once we knew all 3 sides, we could use SOHCAHTOA in order to find all 6 trigonometric functions for that angle. Now, one last thing I want to bring up. Trigonometry is made difficult because there's so many different ways of writing the same thing. So we're going to start collecting identities that will help us. Identities are statements that are always true no matter what the angle is. So I'm going to give you two classes of identities based on these definitions. First of all are the reciprocal identities. And this is what we used when we found cosecant, secant, and cotangent. So there are 6 of these. Cosecant is 1 over sine. It's the reciprocal of sine, which of course means that sine must be 1 over cosecant. Cosine is 1 over secant, so secant must be 1 over cosine. Cotangent is 1 over tangent, so tangent must be 1 over cotangent. Notice I may be saying just cosecant, sine, tangent, and so forth, but you always must put the theta after the abbreviation for the trigonometric function. You can never have a trigonometric function without a theta or some kind of angle immediately following it. Now, the second set of identities that we're going to mention, we haven't discussed yet, but they are obvious from these definitions. These are the ratio identities. Now, the ratio identities tell us that even though SOHCAHTOA gives us these first 3, we really only need to get the first 2, and from there we can get all the rest. Because if you notice, tangent is sine, b over c, divided by cosine, a over c. The c's cancel, this just gives b over a, which is tangent. So our first ratio identity is that tangent is sine divided by cosine. And similarly, cotangent is cosine divided by sine. And there we have our first 2 sets of identities that we will make use of.